Hi students, welcome to Easy BTech, and today my topic is about multiple integrals. Before that, please like, share, subscribe Easy BTech channel. The multiple integrals means doing integration more than one time to the given function. So more than one time means it is nothing but two times integration or three times integration or more than. Okay students, but your prescribed syllabus is about double integrals and triple integrals. So multiple integral means here students about double integrals and triple integrals. So double integral means integral function consisting two variables. Okay, integral function consisting two variables. So in general integration you learnt about in your lower sections about the integration for existence of one variable only. Okay, so now the double integral means about two variables, and triple integrals means about consisting the given integrand term as three variables. So three variables means in general x comma y comma z only, and in two variables means in general x comma y. Okay students, so there are some of the evaluation steps are there for double integration here. Then the evaluation steps about double integration. Okay, evaluation steps about double integrals. Okay students, so what are the evaluation steps? Which steps we are going to discuss here means here. So double integral consisting of two variables, that means if y is one variable and x is another variable, to do the double integration of a given function, then y limits are as a function of x, and x limits are constants. Okay, this is the one way. So or if x limits are as a functions of y, and y limits are as constants. Okay students, so y limits are as a functions of x and x limits are constant, one way, and another way is here x limits are as a functions of y and y limits are as a constant. It is a 1 and 2, and third one is there here, means y limits are as constants and x limits are also constants. Okay students, so y as a x constants, x as a y constants, and y constants, x also constants. So double integration of a function is denoted by so double integral of function f of x comma y dy dx, because two variables are there here, so that's why we are writing double integration dx dy here. Okay students, okay. So now when applying the first step here, that means y as a function of x and x as a constants here. See here, for example, double integration y is equal to x square to x and x is equal to 0 to 1. Function f of x comma y dy dx is there. Observe here students, y limits are as a functions of x here. See here, x square to x, and x limits are constants, that means 0 to 1. Okay, so if the limits are like this, then y as a x functions and x as a constant, then first we have to do integration with respect to y, and then have to do the integration with respect to x. Okay, and second example, suppose if integration x is equal to y square to y and y is equal to 0 to 1 and function f of x comma y and dx dy. See here, x limits are as a functions of y here and y limits are constant. Then x limits are in terms of variable here. Then at first you have to do the integration with respect to x and then y. Okay, variable limits have to do first integration, constant limits have to do the next integration. And coming to the one more example, integral x is equal to 0 to 1, integral y is equal to 0 to 1, f of x comma y dy dx. So see here the both x and y limits are as a constants. Okay, x and y limits are constants. Then we may do with respect to y at first, or we may do with respect to x at first. Okay, if both limits are constant, we may do with respect to y or with respect to x at first. But one thing you have to remember here, students, here, then if y limits are as a functions of x and x limits are as a constants, then first you have to do the integration with respect to y at first and then with respect to x. And coming to this example, if x limits are as a functions of y and y limits are constants, then at first you have to do the integration with respect to x at first, variable limits first integration, constant limits second integration. So suppose the both limits are constant, then we may do with respect to y at first or we may do with respect to x at first. Okay, students. So now the problems related to this topic. Yeah, the first problem. Evaluate integral 0 to 2 and integral 0 to x e power x plus y into dx dy. So this is the question here. So observe, students, here. First observe the limits here. So here 0 to x was there here. So if the limits are in terms of x here, then this limits belongs to the y variable here. Then please write down here as y is equal to 0 to x, and then remaining limits are for x variable. Then e power x plus y may also be written as e power x into e power y. So at first here the limits was given in terms of x here. That means the first limits are y. Then at first you please write down dy and then dx. Okay, students. Yeah. And integral x is equal to 0 to 2. So here we are doing with respect to y integration. Then e power x is common and y is equal to 0 to x, e power y dy and then dx. So e power y integration is e power y only, x is equal to 0 to 2 e power x and e power y 0 to x dx, because the limits are 0 to x only. So integral x is equal to 0 to 2 e power x, then e power y integration e power y only. Now substituting upper limit minus lower limit. So e power x minus e power 0 and then dx. Yeah, integral x is equal to 0 to 2 e power x, then e power x. So e power 0 is 1 here. Then doing the multiplication, x is equal to 0 to 2, e power x into e power x is e power 2x minus e power x into 1 e power x and into dx. See, I am here writing e power x into e power x, bases are equal, then adding the exponents terms here, x plus x becomes as a 2x here. Yeah, now doing the integration of e power 2x and minus e power x here, doing the integration. Yeah, integral x is equal to 0 to 2 divide the integration, then it will becomes very easy for you. X is equal to 0 to 2 e power x dx. So e power 2x integration, e power 2x by 2, and e power x integration is e power x only. Then the limits are 0 to 2. So because e power 2x integration is e power 2x by and d by dx of 2x here. This is the formula. E power 2x by d by dx of 2x is nothing but 2. So apply the upper limit, at the same time lower limit here. So at first I am applying upper limit, students. In the place of x you are applying 2, then 2 into 2 becomes as a 4. E power 4 by 2 minus e power 2 and minus. So e power 0 is 1, that means 1 by 2 and again minus 1. So that is e power 4 by 2 minus e power 2, and 1 by 2 minus 1, students. 2 is LCM and 1 minus 2, that is minus 1 by 2, and here also one minus is there, then the value becomes as a plus 1 by 2. So that's the answer of this question. Yeah, coming to the next question, one more question. Yeah, now I am writing the question. Second question. Integral 0 to 5 and integral 0 to x square x into x square plus y square dx dy. Okay. So now to do the integration of x into x square plus y square dx dy, within the limits it was given that 0 to x square and 0 to 5. Yeah, at first I am writing the question. So the solution. So observe the limits here, students. 0 to x square was given here. That means these limits are y limits, and 0 to 5 are the x limits. Because in terms of x are there the limits, it gives the meanings that these limits are for y variable only. So before doing the integration 0 to x square, yeah, please multiply with x here, x cubed plus xy square dx dy. So now you write down here, these limits are the y limits and these limits are the x limits. So integral x is equal to 0 to 5 and integral y is equal to 0 to x square x cubed plus xy square. So at first we are doing with respect to y, students. Here why here with respect to y we are doing integration, students? Because the limits are in terms of x here, first limits. So that's why we are doing integration with respect to y at first, and then we are doing integration with respect to x. Yeah, okay, now doing the integration. So the first term is x cubed is there here. So but here we are doing integration with respect to y here, then x cubed as a common, then integral x is equal to 0 to 5. Okay, then integral y is equal to 0 to x square x cubed dy, and plus integral y is equal to 0 to x square xy square dy and then dx. Okay, so with respect to y, students, here we are doing then make it as a x cubed common, then remaining term y is equal to 0 to x square 1 dy, and here also with respect to y we are doing x common, y is equal to 0 to x square and y square dy and then dx. Okay, students, because with respect to y here we are doing x as a constant, that's why x is a common here. So here the value is y square. Yeah, now doing the integration. Integral x is equal to 0 to 5 x cubed. So integral 1 dy is nothing but y within the limits 0 to x square, and x into y square integration is y cubed by 3 within the limits 0 to x square dx. Students, we know that integral 1 dx is x, integral 1 dy is y. So suppose integral 200 dx is there, then 200 as a common, and for 1 dx integration it becomes as a 200x. Okay, so similarly I applied the same formula. X cubed is common, then integral 1 dy is nothing but y only. So now substitute the upper limit and the same time lower limit here. So for the upper limit x square, lower limit is 0, and x into y cubed is there here, students. Y cubed by 3 within the limits 0 to x square. So 1 by 3 common, y cubed 0 to x square here. Okay, then 1 by 3 in the place of y you please substitute x square here, then x square whole cubed. Okay students, in the place of y only we are substituting limits, then the value of y for the upper limit is x square, substitute in the place of y as x square and whole power 3. Okay, 1 by 3 x power 6 is the answer. Now here I am writing x power 6 by 3 and again dx. Okay, doing the simplification, x cubed into x square, that is x power 5 here, and again x into x power 6, and that is x power 7. Okay, I am writing integral x is equal to 0 to 5 x power 5 and plus x power 7 by 3 into dx. Yeah, divide the integration individually. 0 to 5 x power 5 dx and integral 0 to 5 x power 7 by 3 dx. Okay students, yeah, x power 5 integration is 0 to 5 x power 6 by 6. Yeah, when you are doing the integration, no need to write the integral symbol here. Yeah, so x power 6 within the limits 0 to 5 and 1 by 3 common. For x power 7 integration is x power 8 by 8 and 0 to 5. Now substitute the value 5 power 6 by 6 and plus 1 by 3 5 power 8 by 8 is the final answer of this problem. Okay, yeah, coming to the next question, one more problem. 0 to pi by 2 and minus 1 to 1 x square y square dx dy. So observe here students, in this question 4 limits, that means the x limits at the same time y limits are in terms of constants. So there is no particular order while we are doing the integration here. Then you may do integration with respect to x at first and then y, or you may do integration with respect to y at first and then x. It is your choice. That means when we are following this procedure students, if both limits x limits and y limits are in terms of constants only. Yeah, okay, now I am doing the integration of this one. 0 to pi by 2 minus 1 to 1 x square y square dy dx. So at first I am writing dy, that means these limits are y limits and these limits are x limits. Then integral x is equal to 0 to pi by 2 x square as a common. For y square we are doing the integration y square dy and then dx. Okay, yeah, integral x is equal to 0 to pi by 2 x square and y square integration is y cubed by 3 minus 1 to 1 and again into dx. So now substituting the limits of y here. So plus 1 is the upper limit and minus 1 is the lower limit here. Okay. So before applying the limits here, so making 1 by 3 as a common here. This 1 by 3 constant value as a common, and integral x is equal to 0 to pi by 2 x square, and for upper limit 1 minus 1 cubed minus for the lower limit minus 1 cubed dx. Okay. Then 1 by 3 integral x is equal to 0 to pi by 2 x square 1 minus, students, minus 1 whole cubed is minus 1 only. Here 1 minus is there, and again in minus 1 whole cubed again 1 minus becomes as a plus here dx. So 1 plus 1 2 and 2 by 3 as a common, 0 to pi by 2 x square dx. 2 by 3 x square integration is x cubed by 3 0 to pi by 2. 2 by 9, here 3 into 3 9 students. Then I am applying upper limit for x cubed, that means pi by 2 whole cubed. Then 2 by 9 pi cubed by 8. Then final answer is pi cubed by 36. Okay. And one more problem. The fourth problem. Yeah. Evaluate integral 0 to 1 and again integral 0 to 1 1 by root of 1 plus x square and root of 1 plus y square dx dy. Yeah, observe the limits here, students. Here also limits are in terms of constant. Then there is no particular order while we are doing the integration here. Okay, so at first I am writing these limits are x limits and these limits are y limits. Then 1 by root of 1 plus x square and 1 by root of 1 plus y square dy dx. So at first I am doing integration with respect to x. That is your choice, students. You may do with respect to x and then you may do with respect to y, because both limits are in terms of constants only. So 1 by root of 1 plus x square common, and then y is equal to 0 to 1, 1 by root of 1 plus y square dy and again into dx. Okay, students. Then integral x is equal to 0 to 1, 1 by root of 1 plus x square. Now coming to this integration, that is 1 by root of 1 plus y square. Integration is sine inverse y within the limits 0 to 1 into dx. It is the formula, students. 1 by root of 1 plus y square integration is nothing but sine inverse y here. And now applying the limits here, upper limit minus lower limit. Okay, and integral x is equal to 0 to 1 and 1 by root of 1 plus x square is as it is, and then sine inverse 1 minus sine inverse 0 and again into dx. Only y only completed here. Then integral x is equal to 0 to 1, 1 by root of 1 plus x square. Sine inverse 1 is nothing but pi by 2 dx. So pi by 2 is common, and 0 to 1, 1 by root of 1 plus x square and dx here have to write here. So because pi by 2 as a constant, then pi by 2 is a common here, and pi by 2, and this is also formula for sine inverse x as 0 to 1. Then pi by 2. The same method here we are applying sin inverse 1 minus sin inverse 0, sin inverse 1 minus sin inverse 0, then sin inverse 1 is nothing but pi by 2 here. So pi by 2, that is pi square by 4 is the answer of this question. Yeah, one more problem. Here 1 plus x square dx. Yeah, okay. Now one more problem, students. Yeah. Evaluate integral 0 to 1 and again integral 0 to root of 1 plus x square 1 by 1 plus x square plus y square dx dy. Okay, it is x square. Yeah, observe this question. The limits, the first limits which was given in this question are in terms of x here, that means 0 to root of 1 plus x square was given here. Then these limits belongs to the y only here. Okay, then at first 0 to 1 and y is equal to 0 to 1 plus x square and 1 by 1 plus x square plus y square dy dx. So because the limits, first limits are in terms of x, students. So if the limits are in terms of x here, then that limits belongs to the variable y here. Then have to do the integration with respect to y at first. Then for this integration, we are using put p is equal to root of 1 plus x square. Here we are not applying substitution method, students. Just we are substituting the value of p is equal to root of 1 plus x square. Then the value of p square is 1 plus x square. Then x is equal to 0 to 1. Integral y is equal to 0 to, see here the upper limit is root of 1 plus x square. According to this substitution, root of 1 plus x square is p and 1 by, so 1 plus x square, in the place of 1 plus x square I am writing p square using this substitution, and plus y square and dy and into dx. So now doing the integration. So integral x is equal to 0 to 1. So in integration we are having one formula, a square plus x square dx is 1 by a tan inverse x by a. Okay, applying that formula. So 1 by a means 1 by p and tan inverse x by a means y by p. So within the limits 0 to p and then dx. Yeah, integral x is equal to 0 to 1, 1 by p. Apply the upper limit, students. In the place of y only you have to apply. Then p by p minus tan inverse 0 by p dx. Okay. So now coming to the integration, x is equal to 0 to 1, 1 by p tan inverse 1 minus tan inverse 0 into dx. Okay, students. So now substituting the value of tan inverse 1 here. So what is the value of tan inverse 1, students? So tan inverse 1 is pi by 4 here. Okay. Tan inverse 1 value is pi by 4. I am doing the substitution. So integral x is equal to 0 to 1, 1 by p. Tan inverse 1 is pi by 4. Tan inverse 0 is 0 into dx. So now pi by 4 as a common. integral x is equal to 0 to 1 by p into dx. So now substituting the value of p, students, here. So what is the value of p? P is root of 1 plus x square. Okay, substituting that value here, that is equal to pi by 4 integral x is equal to 0 to 1 by p value is 1 plus x square dx. Okay, the y integration is completed here. Finally we get the value here as integration x is equal to 0 to 1 by root of 1 plus x square here. Then the integration of this thing is sin h inverse x within the limits 0 to 1. So pi by 4 into sin h inverse 1 minus sin h inverse 0. Then pi by 4 sin h inverse 1 and sin h inverse 0 is nothing but 0 only. Okay, thank you, students. Please like, share, subscribe Easy BTech channel.